Hey everybody, it's Miss Berry. In this video, we are going to be talking about place value as well as decimal place value. So whole number place value and decimal place value. So just to do some quick review of whole number place value and decimal place value. So we see our decimal point here in the middle in red. To the left of the decimal point, we've got our whole number part. And then to the right of the decimal point, we've got our fractional part. All right, so whenever we're moving to the left from the decimal point, we've got the ones, tens, hundreds, thousands, and so on for our whole number part. To the right of the decimal point, we've got our tenths, hundredths, thousandths, and 10,000ths, and so on. All right, so a tenth, any number that is in the 10th place, say for example, there's a 4 in the 10th place, we would say that that represents 4/10. If you had let's say you had 5.34. If I'm reading this out loud, I would say 5 and 34 hundredths. Right, so the 4 is in the hundredths, so I would say 34 hundredths. If it was just 5.3, I would read that as 5 and 3/10. 5 and 3/10. Expanded form is what we're going to talk about really quickly here. Expanded form is a way of writing a number to show the value of the individual digits. We're seeing this in 4th and 5th grade in the Georgia Math Standards. Although you may see some teachers teaching it before then. So let's work through an example of writing a number in expanded form. This is something you're going to see in the homework as well. It says write the number 3,618 and 95 hundredths in expanded form. Right, so you're going to start with the whole number portion. All the way to the left, we see a 3 that's in the thousands place. So it's going to be 3,000 plus the 6 is in the hundreds place, so 600 plus 1 is in the tens place, so 10, 8 is in the ones place, so 8. Right, so 3,000 plus 600 plus 10 plus 8 plus, then we've got 9 in the tenths place and 5 in the hundredths place. So we've got our whole number portion, 3,000 plus 600 plus 10 plus 8 plus, then we've got 9 tenths plus 5 hundredths. All right, so you'll see this in the homework, something just like this. And that is how I'm expecting you to write it out. Some people will take it one step further and they'll change this 3,000 to be 3 times 1,000. They'll change the 600 to be 6 times 100, the 10 to be 1 times 10. So basically just separating it into the digit times its place value. But for our purposes, to me, this looks a little bit neater. All right, the next thing I want to talk about is powers of 10. 10 to a power is called a power of 10, and it's equal to the product. Product means multiply. Right, so it's equal to the product of that many tens. Right, so for example, if you had 10 to the 4th, that is a power of 10, and that is, let me show you what I'm referencing here. That is equal to the product of that many tens. So this is equal to, whoops, sorry, there we go. Equal to the product of that many tens. So equal to the product of 4 tens. All right, so we're going to look at some problems that relate to powers of 10. All right, so 10 to the 3rd. It's going to be equal to the product of that many the product of that many tens. So it's going to be 10 times 10 times 10. Now, if we are multiplying a number by a power of 10, we have this little shortcut we can use. We don't need to plug it in the calculator. In fact, on these problems on the homework, I think I specifically ask you not to use a calculator. I don't mind if you use the calculator to check your work, but I don't want you to use the calculator to find the answer. So I want you to do the problem by hand or in your head, and then you can use the calculator to check your work. Okay, so we are going to be multiplying and dividing decimal numbers by powers of 10. All right, so if you are multiplying by a power of 10, you're going to move the decimal point to the right. All right, and how many places do you move it to the right? It's whatever the exponent is. So whatever the power is on your 10. And if you are dividing by a power of 10, then you're going to move the decimal place to the left. And how many places are you going to move it? Well, that depends on what the power is on that 10. So the power is going to tell you how many times to move the decimal, and whether you're multiplying or dividing is going to tell you whether you move it left or right. This is definitely something that you're going to want to have on your formula sheet when it comes time to take the test. You can see more information about the formula sheet in the weekly announcement, or you can email me any questions that you have about it. But this is definitely something that you're going to want to add to that formula sheet. All right, so let's look at an example. It says multiply or divide as indicated. This one's a multiplication problem. All right, we know that whenever we are multiplying by a power of 10, we move the decimal to the right. And how many places do we move it? That's determined by the power on the 10. All right, this one has a power of 4. It's also called the exponent. All right, so this one has a power of 4. So we're going to move that decimal to the right 4 times. All right, so move the decimal 4 times to the right. All right, so we're going to move that decimal. Ready? 1, 2, 3, 4. Any blank spaces get filled in with a 0. Right, so that decimal just moved. So that's 672360. Then you can go back in and add in your commas. There, that comma goes after the 2. So 600, excuse me, let me see if I can say this right. 672,360 is our answer there. All right, next we are dividing by a power of 10. Remember, if we're dividing by a power of 10, we're moving to the left. And how many times are we moving to the left? Well, that's determined by the power. This says we should move to the left 3 times. So moving to the left, we know it's left because of the exponent, or excuse me, because of the division. So division tells you to move left. And the 3 tells you how many times to move it. Sorry, that looks like a serial killer wrote that. All right, now we're going to move that decimal to the left. We're going to move that decimal to the left 3 times. Let me erase all that. Okay, that looks better. All right, so there's our number. We're going to move the decimal to the left 3 times. So 1, 2, 3. So the decimal point is going to go before the 4. All right, so the decimal point goes before the 4. All right, sorry, we got interrupted. I have to pause the video. So the decimal point is going to go before the 4. All right, so there we go. You can see I put a 0 in front of the decimal point. It's not necessary. It doesn't, if you don't put the 0, your answer is not wrong. But in certain fields and maybe for kids, it is important to have the 0 first, I feel like, because that's going to indicate to them that this is a number that's less than 1. Right, so you don't have to put the 0 in the front, but it's a good practice too. All right, here we've got another multiplication problem. That means we're moving the decimal to the right. And how many times do we move it to the right? That's determined by the power. There's no power here, but we can assume that there's a little 1 there. We can go ahead and write that in. There's an understood 1 there. So that tells us we're going to be moving to the right 1 time. All right, so move the decimal place to the right 1 time. All right, and there we go. Moved it to the right 1 time. That became 686 and 48 hundredths. All right, one more. We've got a division problem, and we've got a power of 2. We've got 1026 and 68 hundredths divided by 10 squared, or 10 to the power of 2. We are going to be moving to the left because it's division, and we're going to be moving to the left 2 times. All right, so move that decimal to the left 2 times. 1, 2, that becomes 10, and 2,668 ten thousandths. That one was hard to say. All right, reading decimals out loud, kind of ironic since I was struggling with reading that last decimal. Reading decimals out loud and writing decimals with words. Another topic that we're seeing in the Georgia math standards. All right, so we are seeing this in the 5th grade Georgia math standards. In the Georgia math standards for 5th grade, we're seeing reading. How do we read, write, and represent decimal values? Sorry if you can hear my kids in the background. It says, you read a decimal by using the words to show the place value of the last digit of the decimal. When you're pronouncing decimal numbers, the decimal point is read as and. No other instance of the word and should appear in your pronunciation. It's really easy to keep throwing in the word and, especially if if you're just used to doing this casually, you might insert the word and in other places, but it's important that whenever you're reading this to your students that you're using the correct pronunciation, modeling the correct pronunciation for them. All right, so we're going to write out how we would say each of the following decimal numbers with words. So we've got 1,848. 1,848. I'm not a stickler for spelling, so if you're doing this on the test and you spell it wrong, it's no big deal. Right now we've got 12.5. That's how I would read it, like to my college algebra class. But of course, if you're reading this to your 5th grade students, you would say 12 and 5 tenths. 12 and 5 tenths. All right, next we have 6.47. If we were correctly pronouncing that, we would say 6 and 47 hundredths. 6 and 47 hundredths. All right, and then we have 1.983, which we would read as, or write out as 1 and 983 thousandths. 1 and 983 thousandths. All right, and then lastly, if you have more than 4 decimal places, I'm just remembering this right now. If you have more than 4 decimal places, then the standard practice is just to read out the digits. So you would say 4.68794. 4.68794. All right, now we're getting to the fun part, representing decimal numbers using base 10 blocks. So base 10 blocks, this is something that a lot of you will have in your classroom. And this is one way that you can use them. Traditionally, we just use them for representing whole numbers, but you can use them to represent decimal numbers as well. All right, so here are some of our base 10 blocks. We would call this one a flat, call this one a rod, and this one a unit. Flat, rod, unit. All right, so your flats are going to represent your ones place. So this is going to be sort of like the whole number portion of your number. Then our rod is going to be a tenth. And why is that? It's because it takes 10 of these to make a 1. All right, it takes 10 of those tenths to make a 1. And then lastly, our unit is going to be 100 because it takes 100 of those to make up a 1. All right, so flat is our ones, tenth is our hundred, excuse me, rods are our tenths, and our units are hundredths. All right, so let's practice. Here we have a sort of like a flat. This is called a grid here, and it has been partially shaded in. So this is not completely shaded in, so that means it's less than 1. Remember, if it's all shaded in, that would be a flat, and that would be a 1. But it is not all the way shaded in, so we've got, think of these as each little column is like a rod. So we've got 1, 2, 3, 4, 5 rods. All right, so we've got 0 in the ones place because we do not have an entire flat shaded. So we've got a 0 in the ones place. We just counted. Naturally, I've already forgotten. Just count again. 1, 2, 3, 4, 5. 5 rods. So we've got 5 in the tenths place. And then our hundredths, that's going to be this partially shaded rod. So let's count the individual little unit blocks. 1, 2, 3, 4, 5, 6, 7. So 7 in the hundredths place. All right, so this shaded grid represents the number 0 and 57 hundredths. All right, now we're going the opposite direction. So we're given the decimal number and we're supposed to shade the grids appropriately. So we've got 3 grids here. Our number is 2 and 73 hundredths. So we're going to shade in 2 grids completely to represent the 2 in the ones place. All right, so shade that in. Shade that in. All right, now we're getting over to our last one. This is where we're going to be representing the 73 hundredths. So 7 in the tenths place, that means we need to shade 7 of these rods. 1, 2, 3, 4, 5, 6, 7. All right. And then we have 3 in the hundredths place, so we need 3 more little units. You can shade the 3 at the top, the 3 at the bottom. You can shade 3 little random ones. It doesn't matter. Right, I'm just shading the 3 at the top. Right, so there's 2 and 73 hundredths. All right, this was a question that I found online that said it was a very commonly missed standardized test question for 4th or 5th grade, maybe 5th grade. It says the distance in meters that 4 students jumped is modeled below. List the students' names in order of greatest distance jumped to shortest distance jumped. All right, so we've got 4 students here, and they've each got their own little shaded grid. We're supposed to write out the students' names from the shortest distance to the smallest to the, oh, sorry, I said that backwards. We're supposed to write them out in order of greatest distance jump to shortest distance jump, so longest to shortest. Okay. All right, so let's take a closer look at each student's little grid. All right, so they've each got one whole grid shaded, so that means they each jumped. All right, so looking at Marisol, we've got one whole grid shaded, and then let's count how many rods that Marisol has shaded. So 1, 2, 3, 4, 5, 6. and then 3 of the little squares, so that's 1.63 or 1 and 63 hundredths. Now let's look at Benito. All right, so for Benito, he's got one whole grid shaded, and then he's got 1, 2, 3, 4, 5 rods. So 1 and 5/10. 1 and 5/10. Now, who's in the lead so far? Who's jumped the farthest? It would be Marisol, right? Marisol has jumped the farthest so far. Now let's look at Otis. Otis has one whole grid shaded, one flat shaded. Now we've got 1, 2, 3, 4 rods. So 1 and 4/10. All right, so Marisol's still in the lead. For right now, Benito's in second place. Otis is in third place. Let's check out Angie. Angie's got one whole flat shaded, and then she's got 1, 2, 3, 4 rods shaded. Now let's count her little units. 1, 2, 3, 4, 5, 6. All right, so that's 1 and 46 hundredths. So she did not beat Marisol, but she did beat Otis, right? So right now Marisol's in the lead, then Benito, then Angie, then Otis. All right, so Marisol had the greatest distance jumped. Otis has the shortest distance jump. So for the long jump, it goes Marisol, then Benito, then Angie, then Otis. All right, so now it says, suppose you have a student, Caleb, that says that 1.46 is greater than 1.5. Right, so maybe he thinks 46 is bigger than 5, so 1.46 must be bigger than 1.5. Using some type of manipulative, try to explain, think of a way that you would explain to Caleb why he is wrong. All right, so pause the video, take a minute, think about what you might do to explain to Caleb why he's wrong. All right, so many answers are possible here. I would probably use base 10 blocks or money. If I was using base 10 blocks, then you would pull out your flats, your rods, your ones, and you would be able to show Caleb that having 5/10 is more than, so having 5/10 is more than 46 hundredths. So that's probably what I would do. But many answers are possible there. All right, so for our last topic, representing decimals on a number line. Decimal numbers fill in our number line. So if you're thinking of a regular old number line that goes 0, 1, 2, 3, 4, or -3, -2, -1, 0, 1, 2, 3. The decimal numbers are what fills in those little blank spaces in between the whole numbers or the integers. All right, so you can think of plotting decimal numbers on the number line in stages based on if the decimal is expressed in tenths or hundredths or thousandths. So the first stage is to place the integers on the number line so that the consecutive integers are 1 unit apart. Of course, the positive integers are to the right of 0 and the negative integers are to the left of 0. Right, so there's our number line. We put our integers on there. You can see that they are placed in the correct order, so that's what the consecutive part is referring to. So -3, -2, -1, 0, 1, 2, 3. All of our little decimal numbers are what fill in the little blank spaces in between these integers. All right, next stage, it says stage 2, decimal numbers that have entries in the tenths place but no smaller place are going to be spaced equally between the integers. You're going to break each interval into 10 smaller intervals, each 1/10 of a unit long. All right, so we're looking in between. Let me see, show you where it's pointing this out. You are breaking each interval into the little space between consecutive integers. So we're just looking between two of our integers, so between 0 and 1. That gets broken up into 10 smaller intervals. That means you're going to have 9 little tick marks. All right, so count them, 9 tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, why 9 tick marks? Because that breaks it up into 10 little intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the little pink spaces in between the tick marks, that's our little our intervals. Right now, this, so we're starting here at 0. This would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, or 1. All right, so this is 0.2. This is 3, 4, 5. This is 0.5. 6, 7, 8. This is 0.8. All right, sorry I got cut off there. But now you can see I've labeled these all 0.1, 0.2, 0.3, 0.4, all the way to 0.9. All right, so now we've got this broken down into tenths. But what if you have a decimal number that's got an entry in the hundredths place? Well, then you've got to zoom in even further. So you can think of each stage as kind of like you're zooming in into an interval. All right, so if you are zooming in even further, if you've got a decimal number that has an entry in the hundredths place, then you're going to zoom in even further. You're going to look in between 2 of the previously plotted decimal numbers, so maybe in between 0.1 and 0.2, or between 0.6 and 0.7. And you're going to, once again, break that into 10 smaller intervals. All right, so maybe we're looking in between 0 and 0.1. All right, then you would break that once again into 10 intervals using 9 tick marks. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 little intervals. Then you're going to label those 0.01, 0.02, 0.03, 0.04, all the way to 0.09, and then 0.10. All right, so each time you're zooming in, think of it like you are just zooming in further and further and further into this number line. And then if you were going into the thousands place, you would go in between both of these. So you could go in between 0 and 0.01. Zoom in even further. All right, you could continue to do that. You could continue to do that as much as you needed to. All right, so here we've got an example. It says plot 0.8 or 0.8 on the number line. All right, so this is a decimal number with an entry in the tenths place, but nothing smaller. So we're just going to plot our 2 integers that this is in between. This is in between 0 and 1. I know that because the whole number portion is 0. All right, so this is in between 0 and 1. Now I'm going to write my tick marks. Remember, always 9 tick marks. Now we're just going to count over 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Feel free to pause the video if you need to catch up. And then we're just going to plot a little dot there. There we go, all done. Right now we've got a negative number that we're plotting on the number line, so negative 0.65. This has decimal entries in the hundredths place, but nothing smaller. So we're going to need to go in between the tenths place for this one. So we're going to go in between, if it was positive, we would go in between 0.6 and 0.7. So it's negative. We're going to have to go in between negative 0.6 and negative 0.7. Right, negative 0.7 is smaller, so it goes on the left. That's important. Negative 0.7 is the smaller number, so it's going to go on the left. Negative 0.6 is the larger number. It goes on the right. So now we are breaking this interval up into 10 little sub-intervals using 9 tick marks. Then we can label the tick marks. Sorry, I forgot to do that. That'd be negative 0.61, negative 0.62, negative 0.63, negative 0.64, negative 0.65. All right, and then you could continue to label negative 0.66, negative 0.67, negative 0.68, negative 0.69. And there's our little number, or our little dot. All right, and then last one, plot negative 1.2 on the number line below. This has got a decimal place in the tenths place, but nothing smaller. So we're going to go in between the whole numbers. And this just takes practice to remember how to do that. As you do this at the beginning, you may have to refer back to the rules. So negative 1.2, we're going to go in between negative 1 and negative 2. In between negative 1 and negative 2. So negative 1.2, imagine like this is the amount that's in your bank account, negative $1.2. Right, so imagine if you had negative $1.2, negative $1.20 in your bank account. If you were plotting that on the number line, that would go in between negative $1 and negative $2. Okay. So now we're going to do 9 tick marks in between this. That's going to break it up into 10 intervals. Then we can just count over. Negative 1, negative 1.1, negative 1.2. All right, y'all. That was everything for this chapter, or for this this lesson. I appreciate you watching the whole thing, and I hope you will let me know. You can email me if you have any questions. And I'll see you guys in the next video.